Okay, good morning, good afternoon. Hope you guys had a wonderful weekend. I am exhausted. We had a huge garage sale. So I was helping my parents out with that. It was like 6 families worth of stuff, and so it was pretty neat though. But I am exhausted. It's like I need a break from the weekend. Oh, all right. So let me share my main monitor. And if you notice, we were talking about, at the beginning, we're going to finish section 2.4, and if we don't get through 2.4 or to 2.5 today, that's fine. We're a day behind, but it actually works out, and I'll tell you why when we look at our calendar. Can you guys look in my math lab? Isn't the quiz due, I think it's tomorrow, isn't it? 9- what is tomorrow's date? I don't even know what today's date is. What's today's date? Okay, thank you. Tomorrow, 9/10. Oh, shoot. Thank you. Oh, come on. That's so picky. Okay, so tomorrow, 9/10. But if you can, do an attempt tonight so that if you have questions, you can ask them tomorrow and do the second attempt tomorrow. Okay, now in my math lab, there is, so let's open up my math lab. Y'all have that open. And then I want you to find the oh, come on. I think I have to sign in again. I've noticed that the school's computers have been slow today. And Pearson's website, someone told me this weekend it was a little slow, so I sent them a little question, you know, hey, are you guys slow? When are you going to get that fixed? And so forth. So, but you guys can also contact Pearson by going to this help button, and it has all the information there. And that email I sent to sign up for my math lab, way on the bottom of that document, there's also this information too. So if you can't get in at all, at least you can call them or email them or something. Okay, on that front page of my math lab, right here it says web conferencing link, so you can go get to our class this way as well. And what else? If there's too much information here, you just click on the more. Click on the more button, and it'll have the link on the next page. Okay, so to find the calendar, change your color to green if you know to go to the course information area. Change your color to green. And then you scroll all the way down, and here is our calendar. Here's our calendar. If you want a Word document of that calendar, you would go to Course Tools, Document Sharing, and then the first week's helpful documents, click on that, and it's down here where it says Calendar, and then you just open it up. So if you wanted to print that out or write on it or whatever, because I don't think I can write on it. I was going to write on it, but I can't. So anyways, that's where you can go get the course tools. Now, the calendar. Let me make a comment on this calendar. I can't write on here, but I wanted to show you something. We're doing 2-4 today. Tomorrow's 2-5. Thursday is 2-7, or Wednesday's 2-7. Thursday is actually going to be the review. So our test, I'm actually giving you the weekend to do the test, but do not do a test on a bad computer. If you do not have good internet, don't do it on that computer. Okay? So I'm going to give you this weekend to work on the test. You have one attempt, and it's 55 minutes, and you have to start and finish it within 55 minutes. Okay? It's not like a quiz where you have 2 attempts. It's 1 attempt. All right, so we'll get caught up, and so on Thursday we are for sure having review. Any questions you have, you can ask. And you can work ahead. There's this 22 problems, and the assignments button, if you click on assignments, show all. These are all the due dates. So if you notice, I made the test due Sunday night. Okay, and don't start it until you are ready to take it. Don't start until you're ready to take it. But I also have kind of a review document. Scott asked a good question, and other people will. But go under document sharing, course rules, document sharing, and then reviews for test. There's a couple documents there. One of them gives the directions. So on that one, you'll see it says 55 minutes. It'll kind of give all the rules. So it's 55 minutes. There's 22 questions on it and so forth. So you can look at that outside of class. All right. A lot of stuff, a lot of stuff. Any questions you guys have for me? So we are doing 2.4. I just wanted to make sure that you guys, were you guys okay on 2.3, the mixture problems? I'm going to put that up while I take roll. All right. Here it comes. All right, and this is where we left off on mixture problems. Okay, so these are the last two problems we did, and I know some of you had to leave for class, which is understandable, but here's the work, and if you have time right now, go ahead and do number 81. Practice, see, to make sure that you know how to do mixture problems. While you're doing that, I am going to take roll, and you just ask me questions if you have any. How is everyone doing today, okay? Our attendance is a little bit low, but I'm assuming that it's probably because of the E360. So hopefully people are spreading the word. But there's several ways to get into our linked class. My math lab, the email I sent you at the beginning of the semester, and this. Huh? I don't know, Brad. We got lots of word problems today. So I don't know if that's really simple for a lot of people. Whew. I will try to make it simple for you. How about that? Okay, when I call your name, change your color to yellow, please. Wow, a lot of people are absent. Sarah, go ahead, change your color to yellow. Ella, Nathan, Danielle, Jake, Melody, Scott Metesky, John Matthews, Brad. John, did you get my email over the weekend? Tish?
Yes, I did.
Okay, good. Good. I know you were gone the last 2 days, so just want to make sure. Karsten, Naomi.
Wait, the last 2 days?
Yeah, I think. Were you gone Wednesday and Thursday of last week?
No, I was only gone on Thursday.
Okay, thank you. Then I will change that. Thank you.
Thank you.
All right, and Jessica, go ahead and change your color to yellow, and Amanda as well. Okay, so I have the following people absent. Esiosa is absent. Lacey is absent. Derek is absent. Emma is absent. John Jerkowick is absent, and Sunny is absent. Whew, not a good day to be absent. Okay, I'm going to get rid of my video because you don't want to see the top of my head. So, how are you guys on 81? Any questions? You all know how to get 60. Anyone want me to do it? Speak now. Sunny. Oh, okay. When Sunny signs in, then tell him to speak up, okay? Thank you, Scott. Let me know if you want to do, okay, we will do this problem then. Let me scroll up. Okay. Whenever you see a problem that says mixture, then, or you're mixing something, then what I would do right away is you can draw a picture, is you're mixing usually two things, and you're going to mix it into one. Okay, and the two things that you're mixing together is a 30%, a 50% to get a 40% solution. Thank you, Scott. Tell him to speak up when he gets in, okay? All right. Now, how many liters of this, I don't know. but I have 60 liters of that guy, and then when you mix this many liters plus this many liters, how many total liters is down here? I don't know, whatever 60 plus the unknown. Good. 60 plus X. Good. Then the second thing you're going to do is do a chart. Now the picture is kind of up to you, but the chart I want you to figure out. Go for it. Sunny, are you here?
Yeah, I'm here. I was just about to say something, but I didn't want to interrupt you.
Oh, thank you. So you got here okay. All right, thank you.
Yep.
So when you're doing mixture, you're going to have 4 rows and 3 columns. Okay. This first column is going to be, I like to do the percent as a decimal. So I have a 30% mixed with the 50% to get a 40%. And then the second column is going to be like your measurement, like a physical measurement. So we're going to measure it in liters. I don't know how much 30%, but I know I have 60 liters of the 50%. And then you're going to mix them together. And the liters was going to be the X plus 60. Okay. Then to get this other column over here on the right, you multiply the first two. So you got 0.3x, 0.5 times 60, and 0.4 times x plus 60 in parentheses. Then what did we do for our equation? That's step 3. Did we add those two and set it equal to that one? Oh, my worksheet's not. It's kind of missing stuff here. Okay. Are we okay so far? Are you guys able to solve this then? This happens to be 60 liters as well. You guys okay with that part of it? Anybody want to see that? Are you okay? The nice thing about mixture problems is it's done pretty much the same way every single time. Okay? One thing that I wanted to point out in when we did classroom example 8, when you're talking about, like we were just talking about all acid, and then we have this water, what percent of acid or antifreeze is what it was. We'd want to say 0. But if it were to say pure antifreeze, what would your percentage be? 100%. Good. Which would then, as a decimal, turn into 1. So I think that might have been one of the homework problems where it said pure something. So you want to put 1 for a decimal, or which is 100%. Okay. Here, this one was 0% antifreeze. Okay. Now we're going to get into section 2.4. 2.4 has more word problems. Woohoo! Aren't you lucky? Right? Okay. The first word problem is dealing with money. Okay? And denominations of money, such as we're working with dimes and nickels or half dollars or quarters. Okay? So it's not like the money problems we did last week, which was investments. Okay, so it's a little bit different. Okay, when we're dealing with denominations of problems, let's think of, like if I said I had a dime, how much is a dime worth? 10 cents, perfect. Now if I said I have 2 dimes, what would its value be? What would its value be? 20 cents? Okay. So I'm going to come back to this in a minute. But let's go ahead and read the problem. Muhammad has a box of coins containing dimes and half dollars. There are 26 coins, and the total value is $8.60. How many of each denomination of coin does he have? Okay, these are going to be the variables. If we're talking about dimes, what letter do you want to use? Good. So I'm going to say D is equal to, now it's not going to be its value, it's going to be how many. So I'm going to say the number of dimes. It's not going to be the value of it, it's going to be how many there are. Okay. Then what would you say for half dollars? Would you guys use H? Now that's just setting the problem up. Okay, now let's go over to the equation. Yeah, let me scroll back up, Sarah. 23x plus, and you know what happens, Sarah? Oh, this drives me nuts, is when I write on Word documents, sometimes not everything gets copied over. Plus, 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 plus. 23x plus 5 times 0.5 times 60 equals 0.4 times x plus 60. Thank you, Sarah, and I will try and catch that. It drives me nuts writing on worksheets sometimes with tablets. Okay, now, sorry, Sarah, was that good enough? Let me leave it up there. Okay, I will help you, Sarah, at the end. How about that? Okay. Now, if we're going with dimes and half dollars, the first equation is really right here. It says there are 26 coins. So that's going to be your first equation. So how am I going to write that as an equation? The number of dimes plus the number of half dollars is 26, right? Oh my goodness, it's driving me nuts. Okay. Now the total value is going to be my second equation. So I'm going to have to try and explain this a little bit. For the total value, if up here when I was talking about dimes, I knew that I had 2 dimes, but let's say I don't know how many dimes I have. Whatever the amount of dimes you have, you'd multiply by 10 cents to get its value. Okay? So when I'm working on my second equation, how do I know what my total value is? Well, it's 10 cents per dime plus how many cents per half dollar? $50? Good. Per half dollar, that's going to equal your total value of $8.60. And some people like to, on the side of these, number 1 is really talking about the number of coins that we have, and number 2, equation 2, is talking about the dollar amount of the items that we have. Okay, so now we have 2 equations with 2 variables. We want to get down to 1 equation, 1 variable. So what am I going to do? What am I going to do to solve this? Anyone have a suggestion? Okay, you can do a chart, yes, and the book teaches doing a chart, and I like that. But I might do a problem I do it a little bit different. I use what's called substitution. So I'm going to solve equation 1 for either D or H. So if I solve equation 1, I'm going to subtract both sides, H. I have D equals 26 minus H. Then what I can do is I can take this D, 26 minus H, and put it in there. But if you know how to do a chart, I am very supportive of it. So it's 0.1 times 26 minus H. So you're basically subtracting off however many half dollars there are. plus 0.5 times H is equal to $8.60. Now you want to solve. So we're going to distribute the 0.1, so you get 2.6 minus 0.1H plus 0.5H is equal to $8.60. After today, we won't have as many worksheets. I'll be writing on PowerPoints a lot, but you guys are going to have to take notes. So we won't have as many worksheets after today, okay? Just so you know, but it'll be a little bit nicer writing. I won't have all these, the computer freezing up or whatever. Okay, so now I have 2.6 plus 0.4H is equal to 8.60. Yeah, if you want, Ella, I can make, do you want the PowerPoints ahead of time? Okay, remind me at the end of class, Ella, to do that, and I'll show you guys where I'm going to post them, okay? Okay, so you get 0.4H is equal to, what is that, 6? Oh my goodness, see how this drives me nuts? And then divide both sides by 0.4, and what do you get for H? Holy moly. What do you get for H? Good, 15. Now, is that where we would stop? What did we just find out? No, what
Now you solve for D.
Perfect. We saw for, yep, we just found how many half dollars there are. And so now we're going to solve for D. And what's a quick way of solving for D?
Plug it into the equation that you figured out to substitute it in for H.
Yeah, you could do equation 1, which is D equals 26 minus H. That's fine. So D is equal to 26 minus 15. And some people just do that in their head. They know that your total was 26. So if I have 15 half dollars, I have to have 11 dimes. Oh, my patience is running very thin with this stuff. Okay, now with you guys. You guys are wonderful, wonderful. I am very impressed with how you guys are keeping up in the class. Now, if you're not doing so hot keeping up in the class, talk to me. Talk to me. I want to help you. Okay, if you're having problems with anything. Okay, now my computer's freezing up again. Let's see. Okay, I'm trying to slide it so you can see some of the stuff. Holy moly. Oh my goodness, you guys, this is driving me nuts. Good. Okay, Lacey, awesome. How did you get in, Lacey? Because there were other people having a hard time.
I just kept trying and trying and trying. It kept booting me out every single time, like 15 times.
Okay, so did you know in Pearson My Lab, or my math lab class, there is a link on the front page that you can use as well. Did you try E360?
Yeah, I was going through E360.
If E360 does not work, then use Pearson.
Pearson?
You know, or my math lab. Right on this front page in my math lab, down towards, or right here, it says click here to join our class.
Oh, okay.
Yep.
Okay.
So there's another way, and let's see, Pearson's down too, at the beginning, the very first, before class started, I sent you guys an email with an attachment that also has the link there. You know, when you signed up for my math lab and all that stuff, and there's a link in that email too.
And how do you get to my math lab? Google it or something, or?
It's that www.pearson, you know how you do your homework?
Oh, okay, yeah.
It's on that first page when you do your homework.
Well, I usually just go to 360 and go through the link.
That's what I discovered today. Most people are doing that. So here's another way to get to it, okay? Pearson My Lab, where we do our homework. Okay, now 82, I'm going to let you guys do that on your own, okay? We're going to go down, I gave you the answer. We're going to go down to motion problems. And motion problems are people's favorites. Haha. Okay. motion problems, we did a couple days ago, but they were very simple motion problems. We are, Lacey, on that worksheet that I gave you, and I believe we're on the last page now, right guys? We're on classroom example 2 under section 2.4. Okay. When we were doing problems that dealt with like rate and distance, what was that formula we used?
D equals R times T.
Perfect. Okay. So we are going to be using that formula, but that's part of the problem. It's a very small part of the problem. When we're looking at these new problems, we're talking about vehicles traveling or people walking, but you have, I think we're only going to be dealing with 2 things at once. So like in this problem, we have 2 cars. In the next, we're going to do this practice problem. We have 2 people. Okay, and then, or it could be 2 different vehicles. It could be a train and a bus. So when you're talking about 2 different things, it's a much longer process, but I'm going to walk you through it. Okay? All right, so let's read through the problems first, and we're actually going to do 3 of these examples today because they are motion problems, can be a little tricky. All right, so classroom example 2. 2 cars leave the same town at the same time. One travels north at 60 miles per hour, and the other south at 45 miles per hour. And how many hours will they be 420 miles apart? Woo! Okay, so Lacey, what I want you to do right now, because I know you came in late, and Sunny was a little bit late too, just start taking notes where we are now, and I can help get you caught up after class. Okay, and if you can't stay after class, we'll figure something out.
Okay.
Okay, so the first thing is we're going to draw a picture. Then the second thing we're going to do is we're going to do a chart. And the third thing we're going to do is we're going to write an equation. So it kind of looks like it's going to be like the mixture problems, right? We could have drawn a picture of 2 things being mixed into a third. Then we drew a chart, and then we drew an equation. So it's kind of like mixture, but each part is going to look different. So the first thing, picture. 2 cars leave same town, one traveling north and the other traveling south. All right, so I'm going to draw this picture. Here's my north, and then this guy is going to be my south. And here's the town. Okay. Now, on this picture, are there things that we can add to that picture? Anything about the northbound car? Yep. What about the northbound car? Good.
It's going to be farther.
Yes, it's going to be farther. Why do you say that? Why do you say that?
Because it's traveling faster.
Good. So I'm going to add this little 60 miles per hour here. When you go north, the northbound car was going 60 miles per hour. So yeah, I like to draw that one just a little bit longer. And what's the south one going in? 45 miles per hour. Okay, my picture's a little crowded, so sorry about that. All right, what else there's one other thing on our picture we can label.
Distance.
Good. So would it be accurate the total distance is 420 miles like that? Okay. That's the picture, just so you get kind of a sense of what's going on. All right, now on the chart, we're going to draw a chart. And remember how before it had 4 rows? We're now going to have 3 rows, but 4 columns. So it's just going to be the opposite of a mixture. 3 rows and 4 columns. This first column is going to be the vehicle, or if you're walking, the person who's walking. So I'm just going to label this one car. And the first one I'm going to say the northbound. And the bottom one, I'm going to say the southbound. And I had it right outside the box because I didn't draw my boxes big enough. So either the northbound car or the southbound car. Then when I do my charts for motion problems, I always put my rate first and then my time second. And I'll explain why later. Okay, and then my last column is going to be D. So when you do these motion problems, for right now, that's the chart, draw it the same. So this is kind of like your template right now for the chart. Now we're going to go in and we're going to fill in the chart. So can we put anything in this first box right here? Would be 60? Okay, good. The rate for the northbound was 60 miles per hour. And the speed of the southbound, 45. Okay. What about the time? It doesn't really talk about the time. Good. So what can we put in for here if I don't know it? That's your X. Good. And I like Karsten. Karsten says T. I like T because of time, but I don't like to write T. So I'm going to put X, but I like, Karsten, if you use T, then when you're done with your problem, you know you just found the time because it's the letter T. So I like that. It's just, sometimes when I write my letter T's, they look like plus signs and then everything gets confused. Okay. Now, the only other information in this problem is the total distance, is that they were 420 miles apart. But it actually doesn't go in either of these boxes because I don't know how far the northbound went. Did I? He didn't travel 420 miles. And the southbound did not travel 420 miles. So what I'm going to do in this column is I'm going to use this equation. Distance equals rate times time. So I have this column as the rate, I have this column as the time. I'm going to multiply, and I'm going to get my distance. So here I have 60 times x, and this one I have 45 times x. Just so you know, I don't think the book does it exactly the way I do. Okay, so I try and teach it the easiest way that I think. But you can certainly look in the book, and, you know, if you like their method, I am completely fine with that. Okay, so that's your chart. Now we have to come up with the equation. And I'm telling you right now, the column we just found is going to help us with our equation. It's going to help us with our equation. Because the column that we found had to deal with distance, our equation is going to deal with distance. But we got to look at the picture, and we have to kind of come up with the equation on our own. And this could be different for every problem. So look at the picture. We're talking about distance, not just one distance, but what distances? We have the distance of the north car, and we have the distance of the, good, south car. And what do we know about the two together? We know their total distance, right? So I want you to look at these three symbols, basically. Distance of the north car, distance of the south car, and distance of the total. And I want you to make an equation out of that. You can use plus signs, you can use minus signs, and you can use equal.
Would it be 420 over 45 equals?
Okay, just look at, you're on the right track, they see, but I want you to just look at this equation. I want you to put a plus sign in there, and I want you to put an equal sign in there. Now look at your picture. Here's the distance going north, and here's the distance going south. Their total distance is the 420.
Okay, so is it 60 plus 45 equals 420?
Good. 60x plus 45x is equal to your total distance of 420. Very good. So Tish, it was like Karsten.